So welcome to our webinar for Unit 6 of the 6th edition of Chemistry in the Community, Atoms, Nuclear Reaction. My name is Michael Murray, and I will be our moderator tonight. I work for the American Chemical Society in Washington, D.C. And with me tonight, we have two very experienced teacher leaders who are amazing teachers and amazing facilitators on Chemistry in the Community. We have Regis Good from Columbia, South Carolina, and Barbara Sitzman from Los Angeles, California. And they will guide you through Unit 6. The three of us will actually give you some feedback on Unit 6 as we go through. Please feel free to ask any questions, and we will try to answer them. I will share those questions with Barbara and Regis as we move along. So we're going to walk through all four sections. So if you have your textbook, if you have a 6th edition of the textbook, please you can use that and walk along with us. If you need a copy of the 6th edition, of course I can't get it to you right now, but if you will send me an email at some point, I will forward that on to our publisher, W.H. Freeman, and they will send you an examination copy. Once again, I want to thank you so much for joining us tonight, and we're going to proceed with the webinar. So Unit 6 is actually, out of all 7 units in Chemistry in the Community, is my favorite. And the opener, this picture that is the opener, is actually my absolute favorite one in the textbook as well. But I find that many times teachers don't get to teach nuclear reactions or anything about nuclear chemistry because it's that last chapter of the textbook and you don't always get there. So I think the way that the information is presented is very accessible for students and actually makes them think about nuclear energy and nuclear reactions in their everyday lives. So I really am pleased with the way that this unit progresses. So, and a lot of teachers use this unit when they need to teach parts of atomic theory. A lot of the history behind the atom is located in this chapter, doing charts of protons, neutrons, and electrons, and isotopes are also in this unit as well. So the unit is going to start in Section A, talking about the composition of the atom. Then you're going to look at nuclear radiation in B, how radioactivity is used, including medical procedures using nuclear radiation, and then finally looking at nuclear energy and looking at nuclear waste and how a nuclear power plant works. All of our units start with these purple boxes at the bottom that ask the students to think about a question. So it says the citizens group wants to ban all nuclear radiation from this fictional town of Riverwood and its surrounding area. And that is how the unit is going to be introduced. So there's this flyer from this company called CANE, Citizens Against Nuclear Exposure, and they want to ban all nuclear radiation in the entire town. And this is presented to the students, so they're given these 14 different facts, or so-called facts, that CANE is proposing to the town. And they're going to work through this unit, and at the end of the unit, they're going to have a town hall to discuss whether this should go through, which is what the flyer is talking about. Now, the students are going to, as they're learning about nuclear radiation throughout the unit, they're going to come back to each of these 14 statements and decide, is the statement true? Is part of it true? Is it trying to be misleading? They're going to have to analyze that. And in one of my favorite activities ever to end the unit, they're actually going to come up with a presentation to present to senior citizens that are in a senior citizens community and that are not necessarily educated about nuclear energy and may have some fears, but they're going to have to discuss nuclear energy and then take that and describe it to the senior citizens so that they can understand the facts. So they're not only going to have to learn the topic and be able to describe the topic, but they're going to have to adjust to a particular audience, which not only allows them to practice their chemistry skills and actually understand their chemistry, but actually practicing their communication skills, which is extremely important, as we all know. So with that introduction, I want to pass the mic over to my good colleague Barbara Sitzman in California, and she's going to lead you through A. And if Regis and I have anything to say as she's going through, we'll chime in and give you some feedback as well. So here you go, Barbara.
Thank you, Michael. I teach at actually the largest charter high school. This is a public charter in Los Angeles. We're part of the Los Angeles school district. And I teach ChemCom to my CP, my college prep kids. They come, they have all sorts of backgrounds and ability levels. Some of them are supposed to be in STEM, but this is the first year with STEM, so a lot of them haven't quite figured out what that acronym stands for and or the meaning of it. So just to kind of give you a little bit of background, I'm working with all kids. Michael's done a good job of introducing this unit, and I find really high interest from students, particularly right now with all of the misconceptions and concerns and things that they're particularly worried about. They're worried about Iran, they're worried about North Korea, and all of the things that they see in the newspaper about this. So this also gives you a good chance to introduce current news with them. Also, I try to remind students that as concerned citizens, they're soon going to be making these kinds of decisions. And although they may not have solutions to all of the problems, at least they will understand the data that they need to be able to try to make some of these decisions at the ballot box. So, as we look at the goals in this section, you might want to remind them as they go over them that the isotopes and radioisotopes were also defined in Unit 1. So if they've been studying the textbook along the way, this is kind of reviewing back to that. So Michael, we could have the next step, next slide. There are concept checks along the way, and I often use these to just sort of find out where my students are, what their understanding is, and certainly to identify misconceptions. Okay, we could move on. As in most of the units in ChemCom, this one begins with an investigating matter, and here students are going to be first recognizing that we need to measure background radiation, and then they have samples that you'll supply for them to measure the radiation in these samples, and then they're going to try to pinpoint exactly what the area of concentration, even in a sample that they're looking at, where it is. So you will need some sort of a radiation detector, some sources. The teacher's addition suggests potassium chloride, that's that salt substitute that you can just buy in the market. And then you see at the right the Coleman lantern mantles, and smoke detectors work well. Potassium-containing foods. If you've got a small radiation detector, you can kind of wander around swap meets and mineral shows and so forth and pick up a lot of things like Fiesta ware and so forth. And so then these are the three parts that they investigate in this lab. Okay, next one. Then we begin with really taking a look at the history of the discovery of radioactivity from Röntgen's fluorescence and the cathode ray tube. I find that tonic water really fluoresces nicely. I have a small little fluorescent detector, and that works well. and that this was the beginning of the cathode ray tubes that are in all of our televisions and computers and so forth now. And then we go and take a look down at the bottom. You will see Becquerel's experiments with uranium and photographic plates and Marie Curie. Okay, we could go on to the next one. Here's a chem quandary, and here we're looking at discrepant events, and Becquerel's was a good beginning of something that came from which was not expected, and Pasteur was the one who said that chances favor the prepared mind, and that's what the students are working on right now. In these three instances, to look at things that came that were really unexpected out of experiments. Okay, the next one is our electromagnetic spectrum, which was introduced actually in the air unit in 2C when they were looking at solar energy and radiation. They studied sunscreens, UV radiation, and so now we're extending it a little bit to include non-ionizing and ionizing radiation to take a look at the things that are involved in the nuclear radiation. Okay. This pictures the gold foil experiment where, again, this was sort of a discrepant event. Rutherford, who is, his biography is absolutely fascinating. I would suggest that you read that if you get a chance. He was the son of a potato farmer, and then he received a fellowship to study in England. So he threw down his hoe and left his fiancée, kids love that, and dashed to England. And from then on, his name became very important in scientific discovery. He was actually working with alpha particles, and they were deflected by something, as you can see in the picture here, and so then he theorized that there must be some little object in the middle of, like in the middle of the atom, the nucleus. Okay, we could move on. So from there, my students have already taken a look at this because they need this information for the California State chemistry test. But we look again at the particles, the basic particles in the nucleus, and just to make certain that students don't misconceive, I read somewhere that I asked students to think of the nucleus. This doesn't work with size, but think of the nucleus as, in terms of the mass, is like an elephant, and the electrons are the little fleas on the elephant. So we don't count them in terms of part of the mass, but they certainly irritate the elephant, and they have to do with all kinds of chemical reactions. Okay, we could go to the next slide. Here they have a developing skills, which is their skill building exercise, and they're going to start looking at nuclear symbols, how we can represent the symbols of that show not just the element, but we can show the mass number and the atomic number. And so then they have a whole section on here where they have different problems, and they work with making certain that they can write isotopic notation. Regis, along the way, if you see anything you would like to add, please.
I know, I was thinking, you're doing a great job, though.
Okay, so I use these little film canisters, which aren't too very easy to find anymore now that everything is digitized. But if you go to camera stores, they often will have some of these, and they don't, they just throw them away generally, or sometimes they recycle them. But you can ask them to save them for you. And what you do in this activity is you find 10 pre-1982, the pure copper pennies, and put them in some canisters and label them such, and then 10 post-82, just in the middle of 82 they changed. So be sure that it's after 82, the newer pennies, and put 10 of them in some containers. So you have pre-containers, you have post, and the kids know there are 10 pennies in each, and then they will need a third unknown that has an unknown mixture of pre and post pennies. Label the outsides of these and include the mass of the canister, the lid, and I put some tape around them to hold them to make certain that they don't peak. And so that they need that mass, that tear, to be able to subtract so that they can find the mass just of the pre, of the post, and of their mixture. And then they're going to use a little bit of algebra. Well, my kids love chemistry, but not when it comes to math. So I really do have to kind of help them when they've got an X that they're trying to figure out. And in the teacher's guide on the margin, they give you some good instructions on how to help kids set up the equation so that they can figure out unknown how many pre and how many post pennies they have in their unknown. And I give all the kids different unknowns. And it really comes out very close.
I was going to say, if you can't find the canister, I've used for years just little tiny envelopes. That way you can lick and seal them and they don't open them.
Maybe that's a better idea because they can pull the electrician's tape off sometimes and try to peek. So
yeah, well, sometimes they would open them too, but just like little key envelopes, little tiny ones.
Mm-hmm. And I often give, part of their grade is based on how well they identify this too.
Exactly.
Not just the lab report. Okay, we can go to the next. Here's your concept check. And again, all of these, there are a lot of concept checks in this section, and I just use them. Sometimes I will use one or two of the questions or all three, but it's basically to find out what kids know and what misconceptions they have. Okay, next one. Here we have the abundance of the isotopes, and this helps students start beginning to understand why those numbers for mass numbers on the periodic table are decimal values, because they are the average of the isotopes based on their percentage. Okay, we can go to the next. Because this here, they're taught how to figure out an average when you have different percentages. And so the sample problems really do a good job of helping them learn how to figure these out. And I find they pick this up pretty quickly. Following the sample problems, there are some problems for them to check their understanding. Okay, next. Okay, the final section in each one of these sections is something that starts leading them toward the putting it all together, the final PIA, as we call it, their presentation for the group of claims that were made by the CANT organization. And I have students work in groups to answer these. They need to revisit that cane poster at the very beginning that Michael showed you. Once they have the answers, I have them write their own answers and share on a piece of paper. And then I keep their group papers, because when they finally come to the point of where they're working out their presentation, they need to go back and look at these papers. And I don't trust my kids to keep them and still have them by the end of the unit. Okay, next. The summary questions are divided into 4 different sections. It makes it very nice because easy for you to assign. I assign these probably in a couple of sets and ask students to finish maybe like the first 2 bullets at the end of the, about midway through the study, and we go over those. And I don't choose all of the questions, just some of them that I think are most relevant. And I tell the kids that this is what I look at when I'm designing their test. So we would do maybe some questions from the first 2 bullets, the first half of the section, and the last half of the section. Regis, how do you handle these?
I do about the exact same thing. But I select the ones that they have had trouble with maybe, or things that I want to emphasize for them to go back and review. So, and again, those are, I do emphasize that these make good test questions.
All right, and then we have one other piece in this section, and this is part of the section summary questions. Michael, if you want to go to the, oh, yes. Is this the one? Yeah. All right. This one is a big section that has green on the margins in the text, but it's right in the middle of the section summaries. And I always ask my students to do their own reflection on the end of at the end of each section. And this particular box is a nice prompt, because if I just ask my kids to reflect, they may not know where to begin. But this tells them what to do, and if you look like at that second paragraph, it even gives them some words and some discoveries, the key discoveries in the words and things that should be in that section summary reflection. So I think that kind of covers what I wanted to cover in Part A. Michael, Regis, did you want to add anything?
I think you did a great job.
Yeah, and I wanted to point out that red question that is in as a part of that reflection question is the exact same question that shows up at the beginning of every single section. So as we switch the slides over to Section B, this red question that says, how do we detect and describe the products of nuclear decay? That's going to be the reflection question that is actually going to be at the end of Section B. So after the students finish the section, they actually get to answer that question that leads them off in the section, which I think is really neat.
Okay, thank you, Michael. And that, you see then, but then along with that, they'll have some prompts of some words that will help them, words and concepts that will help them answer that.
Right.
I don't think those questions can be emphasized too much. I actually talk about them when we start the unit. I then, each time we start a new section, we look at it, and then again, like Barb says, I use them as a reflection. Sometimes I actually use them as an essay question on the test. So we talk about them at least 3 times throughout the unit, each one. So I guess I'm going to do Section B. I'm Regis Good. I'm in Columbia, South Carolina, and a public suburban school. I think it's interesting, just to add real quickly, that I'm in South Carolina, and I consider us a very nuclear state because we have everything. We have nuclear power plants. We have a very high percentage per capita of power plants. We have Savannah River site where they made nuclear material for the military for years. We have a fuel processing plant, and we have waste dumps for nuclear material. So we have it all, and I think it's very important for our students to hear it. So with that, as we move through into Section B, as you can see from the goals, we're going to look at the nuclear, the nature of nuclear materials, look at their properties of nuclear radiation. We'll look at the effects of some of that material, especially ionizing radiation, on human tissue. Students should certainly be able to describe the types of radiations and their effects by the time they finish this section. Next slide, Michael. Another concept check, as Barb pointed out, there are many concept checks. I also use them in this unit, but I also use them sometimes as a way to start the class to remind them what we had been talking about. I like to also emphasize and remind students that the questions, if you're using them all, the first couple questions are really review. Sometimes they're just straight out of their notes, whereas the third question is what we're looking forward to, what's going to be coming up in the next section or next unit or sometime in the future, usually pretty immediate. Next slide. In B1, it's an excellent unit. You don't see this so concise in very many textbooks, but it compares the units of ionizing radiation. And there are many different types of ionizing radiation. So this goes through the different types. It emphasizes that some measure the quantity of energy absorbed per kilogram, while others, like the Sievert and the REM, look at the extent of tissue damage by the radiation, caused by the radiation. So I think this is an excellent, concise explanation of those units. Next slide. Well, the chem quandary are always great to spark a discussion, and I think this one is something that is certainly relevant with their putting it all together. It says, why might radiation exposure standards for some individuals differ for those of others? Students initially don't really think about that, but if you think about people that have fast-growing cells, like children and pregnant women, they should be exposed to something very different than probably a normal adult. People needing medical attention are going to probably be exposed to more. So it's something the kids actually get very involved with when they finally start thinking about it. It's a great way to spark a discussion. Next. This is a fairly traditional activity that's in several textbooks, but I think it's a little more extensive. It has the students actually raise their awareness of the exposure by calculating their exposure, realizing that not all the exposure is from some nuclear weapon or power plant, that it is natural, and some things that they can affect their lifestyles by changing their lifestyles, like smoking and traveling in airplanes. So it is a nice procedure. I like to emphasize, once they've done this, that they look at the units, because it is millirems, and we'll be very shortly talking about rems, which are certainly much larger. And so initially they panic, but we keep emphasizing those units. It's helpful. Next. Here, after we've calculated that, we now look at the factors that determine the actual effects of ionized radiation in that first table and throughout the text. It also looks at how large doses of ionizing radiation can cause DNA damage. And so then the other table that's presented here is looking at the consequences. So students are always fascinated by this, and I find that we end up with lots of good discussions on the exposure and the effects, and are they really in danger. Certainly with the news about people developing more and more nuclear weapons, I think they become more attuned to the fact that this is something we need to be aware of, whether they are a chemist or not. Next. This is an investigating matter that I think is excellent. It is looking at the different types of radiation, alpha, beta, and gamma, by looking at the shielding, at the effects of distance. I've always done this lab as a class demonstration because of equipment. I just have the students make a data table, and then they record the information as I actually perform the demonstration, simply because of the lack of counters. In the text, and I haven't tried this, but in the text Teacher's Edition, it does suggest contacting the American Nuclear Society, because they have a program that helps to distribute Geiger-Muller counters to schools. So that is an option. I think we need to be aware also that most detectors do not measure the alphas, at least most of the ones that we would have access to, very accurately. Barb, do you have any input on counters? Do you have enough counters to do a big scale lab?
No, I certainly don't. So I do need to do it the same way you do as a demonstration.
And I think that's more common than people having multiple meters. But it's still worth doing, I think. I think the kids get a lot out of actually seeing it. They're fascinated by the meter itself, I think. Next. Here they're talking about the different types of radiation decay in terms of what happens and how is an alpha different from a beta. So we're looking at the idea that some atoms or isotopes of atoms are unstable. They decompose by giving off radiation in the form of alpha, beta, gamma. And how do they do that? And we begin to write balanced nuclear equations in this section. Next. So in B6, after they've talked about the different types of radiation, here they're going to actually balance nuclear equations. Actually, they're not really balancing them. They're figuring out the missing part, and they do that by balancing. This, like all the developing skills, has an excellent example of exactly what the kids are going to be doing in the actual activity. This is relatively simple. It makes a great homework assignment. Kids usually don't have any trouble with this. Next. So again, a concept check. The first one's asking about a part of the radiation, talking about not particles but gamma rays, and so they just talked about that. Then they're looking at, I love the question number 2 because it's asking them to compare nuclear equations to chemical equations, really making them realize, there is a difference in terms of what's happening. Then the last question is looking ahead to radon, which is in the next section. Okay, next. This is a rather lengthy reading section. This is a beautiful graphic they have in the section, but it is looking at a present-day problem. It is worth spending time on because it not only a present-day problem, but it is a natural source of radiation that people are exposed to that is not created by humans and can cause severe problems. And it's interesting because it goes into the fact that we solved one problem by sealing our houses so we would lose energy, and created another problem by trapping radon in our basements and actually in some homes. Even though as I look at South Carolina, it doesn't have a large, it's not red, there has been quite an issue up in the upper part of the state with radon that people didn't know of 10 years ago. And so it's also beginning to look at the whole idea of risk and benefits from this analysis.
Well, this is high risk. Just to interrupt for a minute, Regis, this is high risk in my area. I don't know whether that red really extends down well enough to the San Fernando Valley, but we have a lot of radon in the rock in our area, and it gets very hot in the summertime, so people are building more and more homes that are sealed. Fortunately, my house is about 40 years old, so it's got enough leaks in it maybe that we're okay. But kids are concerned, and the local home supply stores and so forth, and hardware stores, you can go in and buy little fairly inexpensive radon detectors to check it out, and some of the kids do that.
Yeah, and that's a good thing to bring into the classroom. So, absolutely. Next. This is a relatively short, lot of graphic, which are great in this section, but it just explains the different types of radiation detectors and how they work. And the kids like this. Next. This is an investigating matter that is a challenge. It can be a challenge. It does work extremely well, but you are creating cloud chambers. Again, this is one that may be best done as a teacher demo and having the students take data, or setting up, large groups within your class to see it if you have enough of the cloud chambers. It does work very well. You may have, you have to arrange to get dry ice that day. You have to make sure that the bottom of the cloud chamber is very flat and has very good contact with the dry ice. But it is something that I really highly recommend practicing before you do with the students.
And you have to have
this isn't too intimidating. The video is amazing. I'm sorry, Barb?
Oh, I was just going to say you have to be certain that you can really blacken your classroom.
That's true.
You just have to make it very, very dark.
But the video that is with the textbook on this is amazing. So if all else fails, make sure you show that.
And that video you can find online at the textbooks companion website through W.H. Freeman.
Okay, good. I was wondering. I was assuming it was still with this edition.
Yes, it is.
Okay. All right, moving on. This is, again, the culminating activity for this section, which again brings them back to their project for this unit. And so here they are looking at a series of proposals for protecting the public, and then discussing their validity. Are they valid? What's correct? What's wrong with them? I certainly do these in groups, like Barb said, and it really is preparing them for the putting it all together. I started off keeping all these in a folder like Barb described and saving them till the end. But our school has gone very electronic, and so we have access to computers within the school, and now they just put it all in electronic folders, and they share it with me and share it with everybody else, and so I even grade it online, so that's been nice. A little different. It's weird for me because I'm old school, but they always have it. So, next. Summary questions. Again, they are related to the original goals. They all tie directly to the original goals, at least at the analysis stage. Is that what it's called, Michael? What's it? The reviewing concepts stage. So these are
reviewing the concepts. They all are analogous to the goals from the beginning.
Right.
Yes.
Right. So again, there are plenty of questions to pick and choose from. I would never burden my students with all of them, unless I had to be out, and they might make a good sub-plan one day. And again, the last slide, Michael, is dealing with that culminating, or the overarching question for the section. And so how do we detect and describe products of nuclear decay? Again, makes an excellent essay question or reflection. It is certainly worth time for having them write a little about it. And then the next slide is a chemistry at work. This is a chemistry at work dealing with Lawrence Livermore. Each unit has a chemistry at work. This one is interviewing a chemist there, a nuclear chemist. The students are always asking about making and finding new elements and from the beginning of the school year. And so this is a really nice, concise little place. They can read about what's happening there and some of the process about making some of the or not radioactive, but well, I guess they are radioactive, but the new elements that we see kind of appearing on our periodic table at times. And I think the pictures are very nice here. It actually has a model of two smaller particles colliding. Barb, any special way you use the chemistry at work?
No, sometimes actually I do have students interview scientists for their first semester project, and so they can look at the chemistry at work in the different sections and get some ideas of some of the things that scientists do that are, you know, maybe away from that workbench all the time.
I like that idea. That's pretty cool.
Yeah, that's a great idea. I also think this one is kind of neat to point out to them about Lawrence Livermore, especially since one of the newest elements is livermorium.
That's right.
So they can actually see the place where the newest element is named after.
And I'm going to turn it back over to Barb unless you have any other comments about B.
No, I think that's fine. So let's move on to C, where we're really looking at the applications of radioactivity. In that, under the goals in that first bullet, you'll see that we're going to look at half-life and radioactive dating. And then when we get down to the third and fourth goals, we're really looking at its use as medical diagnoses and treatment. And then finally, the last couple of bullets, following the study of naturally occurring radioactivity, we're going to look at man-made elements. Kids are always excited about that idea, that you can crush things together and make something else about it. They'd all like to be alchemists, I think. Okay, next slide. Here again, we have a concept check, and so you'll notice the first two, as Regis has pointed out, are things that they have gone over before, and then number 3, we're looking at what's the meaning of half-life. Next. Here, in this section, we're going to look at not only the half-life, which is given in this slide, but it's important for students to understand that half-life is not the same as the rate of decay. The rate of decay, as they point out in this section, is, of course, dependent upon how much of the stuff you have. So it's important for them to just understand the difference between them. Okay, next one. This is a simulation of radioactive decay. They're given 80 pennies, and they can shake them in a box or whatever kind of container you have, and they can look to see whether they decay, whether the heads are up or whether the heads are down, and they can record this by removing the ones which have already decayed and keeping a data table of then in the next half-life, they shake them again and they see how many decay and remove those, and they keep going until they have had almost all of them decayed. And then they take the table that they formed of decayed and undecayed, and they can go ahead and graph this data. You can pool the class together, and they will see then a nice exponential decay curve from this. Now, my kids would rather do this with M&Ms, so around Halloween time, I buy some of the snack packs of M&Ms, and I have them shake these up and dump them on a paper towel, and the ones where the M is on land with the M on the top, after they've counted and recorded them, then they have, of course, they've decayed, so they have to eat them. And they kind of like this idea. And actually, there are only about 19 M&Ms, not 80 like as the pennies that they have, but they still get a pretty nice exponential curve on that. How do you do this, Regis?
I've always done the pennies.
Okay.
The only negative side is it's very noisy.
Yes.
But it's fun. They think it's funny to get to shake pennies around.
All right.
So.
Okay, so we could go to the next one. And this is the developing skills where they actually take a look at half-lives. And this, this exercise, which they can, again, they can do these at home or in the classroom, however it works out best for you. They are given the data for the decay of strontium-90, and they graph that information. And they can see that their exponential curve compares favorably with what they did with their pennies. And my kids always need some help with graphing, and there's lots of graphing in ChemCom, which is really, really good. By the time they get finished, they understand how to graph data, and they understand how to interpret it. Okay? Next slide. Here is the Chem Quandary, and that asks students to recognize that carbon dating really means that you have to do it with carbon-containing materials. That doesn't work for metals, and it really needs to be things that are dead. In fact, one of the distractors I often put on the test question is, you know, what will this work for? And I put Aunt Sally, who lives in Chicago, and want them to recognize the idea that we're looking at things that have a practical limit, as we see at the end, of about 50,000 years. Okay, we go to the next slide. This gives this slide gives the information, and there's some, again, there's just some excellent illustrations here, and gives them both the diagnostic tools and the therapeutic cancer treatments to recognize that these can be used for both tracers, where they're trying to find out what the problem is, and they can be used to treat things like cancer. So at the top part of the data, they have the use, and down below how they are used for radiation therapy. Okay, we could go to the next one. Here's a Chem Quandary, and this stresses that the decay of radioactive isotopes is a fixed value. It's not just that you use something up like you use some other kind of medicine or something, and then use it up and it's gone. It doesn't matter how many people you treat with this, because there is this fixed rate of decay. So I think this Chem Quandary does a good job of emphasizing that idea. It's not something that we can control. We can't just use a little bit of it. It's going to keep decaying. Okay, next slide. This one has one of these excellent Scientific American illustrations showing how the PET scan works. I often start out in this section by just asking kids what they know about PET and MRI. Many of them know particularly about MRIs. They've had imaging themselves from a sports injury, or they certainly have someone in their family who's had to have one of these scanning techniques. So that leads to some questions about it, and this section does a good job of explaining exactly how these work and the benefits of using these nuclear medicine technologies. Okay, next. Here's a concept check again. And again, this third question leads you to synthesis, which is the next section that they're going to look at in C6. And here we are at artificial radioactivity, where we have the helium nucleus bombarding nitrogen to produce oxygen and the byproduct of hydrogen. So now we're looking at transmutation, where we're transforming one element into another in the lab. And it is pointed out to them that this is not something that we can do in our laboratory because a very high activation energy is required to do this. Okay, we can go to the next one. Here's a chem quandary involving this, and students are asked to sort of think, well, you know, if you're going to play alchemist, can you produce gold? So they're asked to try to write some equations for possible reactions and just kind of accept anything that they give you as a possibility. Okay, next one, next slide. Now they're given some sample problems, and they are asked to identify everything in the sample problem, plus locate the missing element. And down below, at the bottom of this slide, you'll see the completed equation, and they're asked to identify the target nucleus, the projectile particle that bombards this target nucleus, and what the product nucleus will be, and what the ejected particle is. And they learn then that they can identify everything by identifying the proper mass number and the appropriate atomic number, and so they can go and they can determine then, in this case, that it is, go to the periodic table and they can see that number 6 is carbon, so they can write that entire isotopic notation for the missing element. All right. The next slide. Now we're taking a look at extending the periodic table, as they say, expanding it to include the transuranium elements. And so we go back in history a little bit, and we look at the 11-inch up at the top left chamber from 1932, and then the 60-inch one on the bottom left, and this was at Berkeley at Lawrence Livermore. And then the large, very large one, 18-meter diameter cyclotron that is in Canada, that's in use now. Okay. C9 is, again, preparing for the PIAT, asking students to look at the scientific concepts that they've learned and evaluate for the community. Look at the quotes that are down below that come right out of the community and evaluate these. How would you, students are asked, and they work again in groups to try to do this, how would you respond to this? And once they've tried to come up with some responses to this based on the information that they've learned in this section, then I ask them to share their group responses. And I have a camera in my classroom that I use, and so the students with our built-in camera, they can put their responses, their answers to these in their composition books or on a single sheet of paper, and they can show this to the class via the camera. And I suppose, Regis, you can have them just do this through the computer, right?
Yeah, it's kind of nice.
So the next one is the section summary questions. And again, we're going right back to the goals again, the 4 sections, and there are, in the textbook, there are questions that relate to each one of these goals. And the final slide in this section is the summary that they can use. And this is what it actually looks like. It has this green margin, left-hand margin on it. And this is where they're looking at this original question. And they do have the prompt that leads them to be able to reflect using the important concepts and the wording and so forth, the vocabulary that's important in this section. Regis, did you have anything else to add to this?
I don't. I think you covered it very well.
Okay, I'll turn you over to Dee.
All right. Well, in Section D, as you can see, it is, I think of it as a risk-benefit section. We're looking at nuclear energy and its uses. We'll look at fission and fusion and look at some of the positive things and also some of the things we need to consider in terms of its risks as we move through this. So I consider this whole section a risk-benefit analysis for nuclear energy. I think it's not only for nuclear energy, it's good for the kids to always analyze for the benefits and risks of any technology or any activity for that matter. The next slide is again a concept check. And so the first question is dealing with something that they learned throughout Section C. And so you can see again that the last question is looking ahead to fission, which is described in the next section. Next slide. In D1, they are now going to be introduced to fission, and they really will just learn what the strong force is. But besides learning about fission, they're also going to start talking about comparing nuclear energy that is released from a nuclear reaction compared to a conventional chemical reaction. I like that idea. They also talk about Einstein's E equals mc squared and why there is so much energy released in terms of the mass defect. I think this picture, which is a core of a fission reactor producing so much ionizing radiation that glows, is beautiful. The kids really don't realize how much energy that is. Next. In D2, they are actually modeling fission. I think this is a fairly traditional, or starts out anyway, as a fairly traditional reaction or activity with dominoes. But they do take it a step farther because instead of just dealing with, like the picture here, the expanding nuclear fission reaction, they also look at a limited chain reaction and having to rearrange their dominoes so it is a limiting chain reaction. It is quite interesting. I think the only negative to this activity is that you do need a lot of dominoes. It's a lot better if you can work in small groups for them to actually try and determine how to make those different types of chain reactions. I guess you can do it as a class demo, but I think they get more out of it if they're certainly doing it hands-on. Believe it or not, I've actually done this with matches. I've even done this activity very similar to this with ninth graders using matches and having them align them and then light just one and see if they will continue the chain reaction. So that's another option if you're not afraid of matches.
You can use ping pong balls too and throw one up and have the kids
right.
throw somebody else and it makes kind of a big mess, but they love it.
Yeah, that's kind of cool too. I like that. Next. In this section, it's a wonderful descriptive sections of how the components and the operation of a nuclear power plant. I find it very important as I'm teaching this or going over it to also explain how a fossil fuel plant works, because they really either don't know or don't remember from an earlier class how that process is. So we end up spending a lot of time comparing the amount of, or how those two plants work and the differences and the similarities. There is a nice graphic of, in that section, of the where all the nuclear plants are in the United States. South Carolina has a lot of spots for a little area. All right. In the next section, we look at nuclear fusion, and the picture here is the wonderful Scientific American picture that has at least one in each unit. So here it's comparing the fission and fusion very, very nicely, and talking about how fusion is certainly been used for military weapons and the problems associated with trying to harness it for energy. So very, very short section, but very highly dense, or dense with good information. And next, we have another concept check. The first question is really dealing with the information presented in D1 through D4, so it's a good review. And then in the next section, we're looking at or trying to analyze what are some of the problems with nuclear energy, which is what leads into the next activity, which really doesn't look like it has anything at all to do with nuclear energy, because they have to calculate the safest journey by taking risk factors of each ways. They're going to travel 500 miles on an imaginary trip, and calculate risk factors for traveling by a car or a bus, airplane. And the students are always quite amazed, as I think most people would be, that the safest is in an airplane and the most risky is on a bike. So it really has them start looking at the risk-benefit of, in this case, of traveling, but in a general activity. In the next slide, they're asked, the chem quandary leads into that, or follows up with that idea: is there a risk-free travel? Or should they just stay at home? Well, is it safer to stay at home? Well, maybe a tree will fall on their house, and then they still have risks. So it gets them really thinking about the positives, the negatives, and everything has risk associated with it. Okay. Next, we're looking at radioactive waste, certainly a controversial and pressing issue in our country and around the world. It describes the difference between high-level and low-level radioactive waste and the various disposal methods. And again, how are we going to deal with this material? We certainly have some benefits from using nuclear energy in terms of environmental lack of emissions, but there are also risks in terms of what do we do with all this waste. So it addresses it very nice without preaching or giving a political standpoint. Next. Here they're have a good set of follow-up questions looking at the high-level versus low-level radioactive waste. And just a real short activity, having them interpret what those are and what they would do with them. And the risk, again, risk and benefits are highly emphasized. Okay. The last section is the final section or activity that they'll do before they actually start putting their their final presentation together. And here they're evaluating statements, the statements from the Kane Flyer related to the nuclear power plants and nuclear weapons. So they're picking out those that deal with that and trying to look at their validity and how they would present them to the senior citizens. Anything else on that, Barb or Michael?
I don't think so. I think you've done a good job of this, Regis.
Okay. Well, just like each section, we have the summary questions dealing with the goals. I think that's, you know, such a strong point in this text. And again, the great question at the end, the section summary question, dealing with what burdens and benefits accompany the uses of nuclear energy, which is the next slide, Michael. I'm sorry. Okay. It certainly provides not just a good reflection on the section, but really the whole unit. It really ties it nicely in terms of these risks, benefits of the nuclear materials. All right, putting it all together. Here they are going to, I have them work in small groups to, they've been assigned a couple of the statements from the flyers that they're responsible for targeting. And then they are responding to those. And I think, Barb, you had some real good information on how you handled that.
Yes, I just, it's too much for them to look at completely. So I give them back their making decisions from the end of each section to look over. But then I have them draw. I put the numbers of the different questions on little slips of paper, and they draw. So it's just sort of by random. They are assigned certain questions to answer and to address, I should say. And then I ask them to look at each one of the statements, and I usually, like you do, Regis, I give them 2 statements that their group is working on, and I kind of mix that up so each group has a different 2 statements as well as I can. I usually have about 11 or 12 groups in the class of 3 each, so that's quite a few groups. And first of all, with the statement, I ask them to specify whether that is true, false, or partially true. They can look back and see what they said in the beginning, and they may have changed their mind about it, and hopefully. And then I ask them to explain the science and the technology that's involved in their decision. And then I ask them to prepare a replacement statement to correct the misunderstandings that were involved in this original statement. Now, this is all information that's pretty well in their textbook, and the directions are from the text. Now, the teacher's resource material does contain a sample rubric, and I always print this out for students. I use some variation of what the teacher's resource material has suggested. That's either from the big binder or it's on the teacher's CD. And so basically the rubric is going to involve their presentation and how well they've organized it, how much time they have been allotted for this, and I just decide I sort of divide up the class time because we need to do it during a regular class period. And I give the students the amount of time, and I have someone timing them. And so how well they adhere to that time limitation, how well organized they are, and how well they assume the roles that they choose. So they have to come up with some kind of role what kind of role they're going to assume in this, or as a student. And then I will ask them to, then I will also grade them on how well they address the statement. Do they really identify well whether it's true, false, or partially true? And how well they use the science and technology that they've learned in the unit to justify how they address that statement. And then I ask them for a replacement statement, what really should be on that cane flyer. And so they have readdressed the original idea, but they have corrected it. And then I ask them about some everyday examples and applications of this information, because it's people will learn the material better. Their audience will understand it better if they can apply this to everyday life. Then I grade them on their visual, their props, and how they present this. And I'm kind of leave them open to this. They can do a video, they can do a PowerPoint, they can do it live, and with posters. They can wear costumes. So I kind of leave this open for them to just do something that makes an effective presentation. By the time they come to the 6th unit, they've done these presentations several times before, so they have a pretty good idea of what will elicit response from their audience. And then I give the other groups a chance to ask them questions, and I grade them on how well they respond to that. So, Regis, how do you do this?
Very, very similar, actually. So, yeah. I like the idea of letting them have the options of how they want to develop the presentation. I
do one final thing, too, because I often have parents who say, well, they work in groups and they all get the same grade for the group.
Exactly.
You know, and my son or daughter did all the work, and that doesn't seem fair. So in all of these major presentations, I have sometimes it's up to 50% of the grade, which is an individual grade. So I kind of worked this out myself. For example, with this one, once I've assigned the questions to them, students need to bring in some information, not just from what they learned in the section, but something reliable from, usually they use an internet source, but some sort of outside information from a newspaper article or an internet source that they bring in that will help them address the claim on the cane flyer. And then that's prior to their developing their PIAT. And then after it, I ask them to write a letter. They've written in the water unit, they wrote an editorial to Riverwood newspaper. This time, since they're addressing senior citizens, I asked them to write a letter to their grandparents or another older citizen advocating the revision that they have suggested to the claim in the cane. Boy, that's sort of a tongue twister, isn't it? And give the rationale for that revision that they investigated.
Yeah, I like that idea. I think it's important to have an individual component, and that's a good one.
So, I see that we had one chat question, which Michael has answered, and so maybe, Michael, I'll just turn it back over to you. Michael?
I'm here. Sorry.
Okay.
If anybody wanted to ask another question, you can pose that now for Barbara and Regis or myself. I know a few people asked me how they could get the textbook. Just send me an email and I will pass that along to the publisher and they will send you one. I sent the website for the textbook. You should see that in the chat, and then or in the question box. And then you should also know that there's several lab videos, and also the Teacher's Edition gives you feedback on how on certain labs that you may want to do as demos, or you may want to do those as the video instead of having the whole class do that. So a lot of those ideas are in the Teacher's Edition, that they're giving you options, because we know that some of the equipment is hard to come by, or also some of the experiments, your room may not be equipped to do those. So we have given you that feedback. So we'll wait just a moment to see if anybody else has any questions. Okay, I don't see any questions, so I want to thank you all for your attendance, and I'm going to thank Barbara and Regis again. And next week we'll be doing another webinar. I will send all of you the information about that as well. So thank you again. I will also send, this webinar will be recorded, so I will send you the link to this so you can see that as well.